Hey everybody, let's do some more stuff in R. And now what we're going to do is look at some things with the factors and do some of the same questions that we did a couple weeks ago, but you'll see how things change up a little bit. So this time, we're still going to be in the car package, and we're going to look at a data set called AMS survey. So you're thinking, what's in there? Let's look. So it's new PhDs in the mathematical sciences. And we're going to look at type. So it's what kind of universities they went to. So there's public and private, and groups 2 and 3, 4 for statistics and biostatistics, and VA for applied math. Sex, so it's gender, citizenship. So these are all factor values, and you will see how they look in a minute. Okay, the count, that's 2008 and 9, and count 11 is 2011, 2012. We're really interested in the latest value. We don't care about the earlier value. So what I'm going to do is close this out, and we're going to have count 11.lm is equal to lm of count 11 tilde type plus sex plus citizen. And the data set is AMS survey. And we do the summary. Okay. So, lots of interesting things here. The type 1 public shows up to be significant. Type 2 is significant. Type 3 is not. Type 4 is. Type VA, the applied math, is not. Male is. U.S. citizen is not. Okay, so you see how it doesn't have all the values in there? So those are the factors, that is the dummy variables. Okay, good. All right, so what we would do here, even though they're not all significant, we would test for the overall goodness of fit. All right, we're going to do that in a second. We'll still have our usual questions, and then we'll see. Okay, so let's consider test overall goodness of fit. Oh, that's interesting. Of fit. Let's just arbitrarily pick test. How about beta 3 equals 0? Find residual standard error. Oh. Find R squared. And find adjusted R squared. Okay, so the test for the goodness of fit, this is very interesting. We're going to use the p-value that's down at the bottom here. So we're going to say beta 1 is equal to beta 2 is equal to beta 3, beta 4, beta 5, beta 6, beta 7. Okay? Good. All right. Even though we only have 3 here, look at all the coefficients we have. We have 7. All right, we don't count the intercept. All right, so we have 7 there. So then the p-value is the 0.000003. Is that less than alpha 05? Yes, it is. Therefore, the model fits well, even though so many of them are out of whack. Okay? All right. Now let's test beta 3 equals 0. So which one's beta 3? Well, this is 1, 2, 3. That is, the type 3 is beta 3. So let's see what the p-value is. It's 0.968. All right, is that greater than, or excuse me, is that less than 05? No. So we fail to reject. Okay, residual standard error, 26.12. R squared is 0.7767. So it's an okay model. Now, look at how much smaller adjusted R square is. It's 0.6786. And that has to do with the fact that there are so many parameters as compared to the n value. So there are n equal 24, but yet we have 8 parameters. So that's like a third of the data set's parameters. So that's why it's pushing it down so hard. Okay, isn't that nice? All right. You like those? Good. So that should be enough in this right now.